let's get started. First, if those of you who want to pick up the midterm, got into time trouble today. You can come back to my office if you want to pick up your papers afterwards, or I'll try to bring them next class again. Any questions about homework 3 or anything else logistically here? Okay, homework 3 is due on Tuesday. Am I correct? What? Homework 2 is due on Tuesday, right? Okay. Homework 3 is on my mind because I'm preparing it, but homework 2 should be what's on your mind. Okay. How are people doing on the homework? Have anybody? How many people have made it pass through the entire assignment to some degree? Okay, I'm seeing a few people twitching. How many people have not gotten started? Okay, less twitching, but okay, that's good. Okay, any questions about homework 3? I'm happy to discuss this a little bit. Yes?
In the fourth question, I think, where you're supposed to get another data set
Right.
system, is there any parameter that we can use to merge the newer data set with this?
Okay, so let's first think about what the purpose of part 4 is, and then we can talk about what you're supposed to do. Okay, so first of all, it is not an unreasonable thing in the world that sometimes you want to take data from, to get more insight into a problem, you need data from different sources. Okay, and this is giving you a way to, a excuse to try to think about that a little bit. Now, there's a question of what kind of data sets can you hope to find that are interesting, okay? And now, there's certainly none of them that are going to be associated where you're going to get data on each individual house ID, okay? Unless somewhere there is data on that. Perhaps if you broke into Zillow's computers and you went back into their system, you could get more data. That's not what I'm really encouraging, okay? But the question is there more data that you can bring to bear in making possibly help you make predictions on housing price? That's really what this is kind of about, right at the end. So what other data sources might help you with predicting price of a house, okay? You guys have some idea. Is there anything else in the world that you might be able to, any more information you can get about Skeena's house that is not looking up Skeena's house in the tax records? Okay? Can anybody give me any ideas of possible information? Yeah?
You can look up the house on Zillow and find maybe the square footage. You can find features of the house. Usually they have listed like.
Okay, so one question is you could go to, if you wanted to find about Skeena's house in particular, you could look at it on Zillow. Okay? Now that's presumably you can't, for the houses you have, look them up on Zillow and get any more information. You can. So you're telling me you have enough of an information about the house, like an address. So do you? This is what I'm curious about. So certainly in Zillow in general, you can find all kinds of things about a house you know of. Do you have the house address? No. You have the longitude and latitude of the house. Is that right? And again, I need help here because you guys are playing with the data. I know nothing. Okay?
You do have the Zillow ID number, which I think you could actually just plug straight in.
Okay. So one idea here, which wasn't necessarily the idea that I thought about, but if this is what you want to do, I'm not objecting to this. One possibility is you have enough information to go onto Zillow's site and maybe get more information. Okay? That's one possibility. I'd like to think Zillow has good enough data scientists that you'll eventually be blocked, but maybe I'm wrong. Did you do that out of curiosity?
I did it for a couple houses, and I did find some information. Not enough to do certain things, but was enough to at least get an idea.
Okay, So let's say that was a pathway. I consider that clever. I have a feeling it's not the answer. Oh, everybody go pound Zillow's website. I doubt that's the right answer. Okay? What other information can you get about a house that might be relevant to a house? Okay? Without necessarily finding out the particulars. Okay? Let's try this one. You.
Something related to the crime rate in that particular.
Okay, so you know roughly where the house is. Okay? There are things about that area that you can find. The crime rate is undoubtedly something. Okay? Are prices in a place with high crime going to go up more or down more? You say down more, maybe. Okay? It could be, actually, that and again, I don't know, I'm just now thinking off my feet, okay? I understand there is a housing shortage. I understand people are desperate for low-priced housing. What do we think about the crime rate by low-priced housing? Is it high or low? You would expect the crime rate could be higher. If you knew that there was a high crime rate here, maybe that's a place where houses are going to be are undervalued now, and so they will kick up in a tight market. I don't guarantee that's going to happen, but it's, I could see do people see how that might happen as a hypothetical thing? Okay, but one way or another, it seems to me knowing the crime rate of the area probably helps, right? Does the crime rate of the United States help? Knowing the crime rate about the United States? No. Does the crime rate, the finer the resolution you have, the more it probably helps, okay? But you won't get infinite resolution down to each house, okay? So crime rate could be something. What other data from the outside about the houses might be interesting?
The actual area itself, the geography of the area, the weather of the area.
You could know. So for example, what we say weather. Okay, now weather from one house to another is probably the same thing. My understanding of Buffalo, however, I don't know if anyone's from Buffalo or anything like that. I get the idea that there's parts of Buffalo where it is ungodly cold, and there's parts of Buffalo where it's ungodly cold and you get ungodly amount of snow. There's kind of some parts of town that get much more than the other because of lake effects or something like that. Could it be that the weather in a neighborhood differs enough to change the price? Probably not usually, but it wouldn't shock me if that was true in certain extreme cases. Okay, so weather could be it. I'm not sure weather is the most promising one. Crime, school rates, things like that. Okay? These seem like things that you could learn that might help. Okay?
Actually, my question was, suppose I've identified a data set
Yeah.
Is useful for making the predictions. How do we actually combine it with the existing?
Okay, so now then, how do you combine it? This is an interesting exercise to think about. Now you need to have, it would seem to me, you want to ultimately produce a record for each house, right?
Yeah, like whatever is possible.
And it seems to me that what you want to add is maybe a crime rate column. And where you say your crime rate estimate for each house. Do you see that that's what the level of integration is? It's not that there's necessarily a key. It's not a one-to-one key between crime rate and house. But it is the case that every longitude and latitude has a crime rate. Okay? And you could put that in as a column for each house. Do you see how that could work?
Yeah, but for that we would need some particular columns to match between the crime rate, like longitude and latitude, right? Between the crime rate data set and.
Okay, now how would you go about integrating so what does the crime rate data have? Okay, I suspect that crime rate data, I haven't seen crime rate data, but it is probably going to tell you by neighborhood or district, okay, what the crime rate is. Is that right? Or what was your crime rate data?
So it had the detail about the county of each.
Okay, for each county, what was the crime rate?
Yeah.
Now then your problem reduces to, for each house, figure out what county it's in.
But yeah, that's
Okay?
There's an issue with that type of data because the crime rate in one part of a, like if you look at like LA's Compton versus Boston.
Okay, so there's a question of you would like the data on a fine enough resolution that it can help, but a coarse enough resolution that you can obtain it, right? Now you're telling me crime rates in LA only go down to the county level. This I don't personally believe, okay? Okay, I believe you have crime rates down to a precinct level, okay, or some finer level. Has anybody found any data like that? Okay.
The best place to probably look would be on the census data. They have a lot of the records for each town. You can actually look up by actual town, and with the way California is set up, they like LA is like actually like 7 cities put together. So like you might be able to find more information that way.
Okay, one way or another, okay, in principle, there exists data to a particular resolution, be it a county or a town or a zip code or a precinct or something like that. And that's going to be true for education test scores, and that's going to be true for crime, that's going to be true for income in a county. Income's a good thing. Is the house price going to be higher or lower where the income is higher? Probably higher, right? It's going to be these people are, if they're wealthy enough to afford a better house, they're going to live in a better place, okay? So how do you turn this into a column? I think what I said was reasonably clear, okay? In that you've got data for a region. You know what region a house is in implicitly, and you can take the data value for the region as the proxy for the value of the house. Now, some of you may be saying, oh my God, I'm nervous about this. How do I do the geolocation? I don't know if that's making you nervous, okay? What is a quick and dirty way to do geolocation? Suppose, let's say, I have depends what the crime is given by. Let's say the crime is given by zip code. Okay, if you know the zip code of the house, that's easy to do the mapping. What if the crime does not naturally, is by precinct or something, that does not correspond naturally to the house? Is there a way of joining them?
You might modify, I guess, the center of that precinct as a latitude longitude, and then have a radius.
Right, so the zeroth order way to do this is you say that every precinct is a perfect circle, okay? The center of the circle is a representation of where the prefix is. And then what precinct is your house in? It's the one that's the nearest neighbor of the center. Does everybody agree that's a quick and dirty way to deal with that? Is that going to deal well with countries like Chile, which are long and skinny? No. But is it going to get you through the homework assignment? Possibly. Okay? And so I urge you to think like that. Again, if there's better geolocation, that's good. You live in a world of Python APIs. It would not shock me if there are better tools that are available to you for geolocating within regions, okay? I would not be surprised if you could get something that, given a longitude and latitude, returns the zip code, for example, okay? But this is for you to figure out, okay? So conceptually, you see how you might do this? Okay, any other questions about this? Yes?
Yeah, I was going to ask about the submission to categories. So they want 6 columns, so 3 of them for
Yeah.
the months of October, November, December for 2016, and the other 3 for 2017. But that housing data we have in the 2016 properties and the 2017 properties file, is that like a yearly granularity? Like, to me, there's no immediate difference.
Okay, so you're saying how you're saying I've only got data on one set of data on the houses. They're asking me for price predictions at different points in time. How can I possibly give, different predictions at different points in time? That's kind of what you're asking. Okay, so here's my answer. Okay, first of all, this is something Kagel did and not me, right? So it's not a completely insane thing that you be able to do it, okay, because they're asking for it, Second, is there any way you can predict that the time value of a house shouldn't be the same at any given time? Okay, let's stop and think about it. The value of my house 10 years from now, is the value of my house going to be more or less than it is today? Who here says more? Who here says yes, less? Okay, my wife says less because we're going to burn it to the ground. But why did you say more? You all knew that. Why is that? Inflation. So is this something that you can estimate or model or predict that is going to be different? The answer is maybe. Okay. Is there something else that you might be able to know or predict? What's going to happen to housing prices when interest rates go up? Okay. Let's stop and think about it. All other things being equal. Do people understand? First of all, I know people understand the concept of borrowing money to buy a house, okay? Let's just clarify this. In America, it is not common for you to save up all the money you need to buy the house and then go and buy the house. Usually what you do is you save up enough money to have a margin, typically let's say 20% of the house, okay? That you then can walk into the bank and say, you give me money, loan me money at a certain interest rate for the other 80%. I will promise to pay you back on this, and if I don't, you will keep the entire house, okay? Including the 20% that I paid. So you know that I'm going to want to pay you back, okay? And, you should feel comfortable making me this loan. So people borrow money to buy houses usually, okay? And when you borrow a fixed amount of money, there is an interest rate that governs how much you pay back each month. The higher the interest rate, the more you pay back. People understand that physics, or any questions about that? If not, this is useful information to know, even if it's not data science. Okay? Now, what happens when interest rates go up? Suddenly, we're going to have interest rates are going to go up. The president decides they have to fight inflation, or the head of the Federal Reserve has to fight inflation. Interest rates go up. What's going to happen in isolation to the price of the house? It's going to go down. Why is that? You have the ability to pay the bank $300 a month. Okay? If the interest rates go up, you can't borrow as much money, such that the payment will be $300 a month. Does that kind of make sense? And so now, no one is going to be able to buy your house if it's too expensive. Okay, so that will naturally cause the price of the house to go down. Okay? So what does this mean? This tells me that there are things that change even if the house doesn't change, right? You might want to do some interest rate modeling. Now, to a certain extent, you're cheating when you look at the interest, if you know the interest rates in the future. But maybe you're not in the Kagel contest now, I'm not going to worry about that. There may be other things that happen with houses as times, okay? Now with cars age at a rate. Does anybody know what happens if you have a car that's worth that costs $20,000? You buy this new car, you drive it a block and you park it. How much is the car worth now? Okay, I hear 8,000, I hear 10,000. Does everybody agree less? There is a curve, decay curve, about how houses change in price, right? About how cars change in price with time. Is there such a thing with houses? Probably to some extent, to a certain degree. That's another thing that's forward-looking, right? So bottom line is, there are reasons why that price could be different. Now, is there anything that's going to stop you from going to Kaggle and submitting one thing with 6 columns that are identical? The answer is no. Might that be the right thing to do? Conceivably. Or it might be that there's reasons why this is a time-varying problem. Okay? So do what you can and not what you can't. That's kind of my proposal here. Okay? Any questions? Again, I say KISS, first make through the problem. Okay? Go through it. Probably at first you might want to make one prediction over time and then worry about if there's time-dependent effects later. Okay? As your schedule permits. Any questions? Any questions about this assignment? Other things about houses, anything else? Okay? Okay, good luck and go on that. Okay? Okay, any other logistical questions before I go? Okay. So what I'd like to do now, let me try to do this, is shift into the topic of visualization, which I sort of hinted at the end of last class. And I want to spend a good couple of classes on this because I think being able to make good visuals, good plots is, a really important skill. And it's one of these skills that is not on some level rocket science. And on the other hand, normal, intelligent people can do phenomenally bad jobs, despite that, okay? So it's one of these things that's harder than it looks, okay? So let's look at some plots that people turned in on the first homework as being trying to tell a story. And I want us to start pretending we're art critics here. What's good, what's bad, okay, about this plot, okay? So what is this plot? And again, some of these are plots from class. If you see your plot here and it was not, I don't deem it a good plot, don't feel bad, learn and do better in the future, okay? Okay, what do we think about this plot? It looks like this is plotting returns as a function of, a frequency of returns. Good plot or bad plot? To me, the question of is it informative? Okay? I think, to me, this is informative, okay? What am I seeing? I'm seeing yes, the returns are a bell-shaped curve around 0. Are the returns normal? Is the distribution of returns normal or not? They show a normal curve as well that kind of fits this. Who here believes these distribution of returns is normal? I see some people twitching. Who here thinks this is not normal? More people. Actually, it turns out that return distribution is not a normal distribution. It turns out it's log normal, okay, which means, in effect, first of all, you do have a bigger peak in the center, and you do have longer tails. That's something that's maybe less clear here. Maybe it is or is not on the thing, where rare events happen more often than you would expect on a normal distribution. Okay? So this to me reveals a lot of things. I might have wanted to see a finer histogram, more buckets. Okay, might have made this clearer, because sometimes as we talk about histograms, how things look with number of buckets is such. But I think I learned something from reading this. Any questions? Okay. Here's another one, okay, that's trying to show the same thing, a distribution of daily returns. Good plot or bad plot? Okay. I don't think I learn as much from this. Why don't I learn as much from this? Okay. Well, for one thing, where all the action is here. Where all the space is here. Okay? So this is showing there was some kind of weird point, okay, where something went out to 14% per day, which I still find surprising. I don't know what that means. But whatever, here an outlier is dominating the view. Do you agree? This is, I call this the tail wagging the dog, okay? And, you know, so I don't think that's a good plot. Is this a good plot or not? Okay? Can you tell what this thing is doing? They seem to be, if in my mind when I look at this thing, they're looking at each country, at each state, and they're telling me where was the company based and what was their average earnings per share. Okay? And when I look at that, that's what I think I'm seeing here. Okay? Okay, is this a good or a bad plot? Okay? Do we see things here that look interesting? What's interesting? I saw people nodding. What's interesting? What do you find interesting? Anybody with a hand? Yeah?
We can find the difference between the states which are far, not for example which are near, because if they are near, they have some intersections that they are not obvious that what is the difference and which one is bigger or smaller.
Okay, so some states, okay, so size presumably is reflecting, I'm guessing, the number of companies in that state. Okay? And one thing you're saying is the number of states where the number of, if that's true, certain states have a lot more companies in it than others, right? And they may be weird places. Which state is it that has the biggest bubble here? I think that's Arkansas. If this is right, that looks like Arkansas. Okay? Now, I can think of one company I know is based in Arkansas. Can anyone name a big company based in Arkansas? Walmart is famous. Okay, is that the one you were going to name? Okay, good. But, so what, you naturally want to ask yourself, why are certain states overrepresented? Okay? My guess is it may have to do with incorporation laws and tax rates and things like that, but I don't know. And then they're showing profit, average profit by some state. For some reason, it looks like, which state is this? Is this Tennessee or Kentucky? Tennessee. It looks like Tennessee. If you want to become profitable, you move your company to Tennessee. Okay? I'm not sure whether that's significant or not, okay? But we had something to talk about here. Okay? So if these numbers are right, they provoke discussion, and that's interesting. Okay, here is another plot, okay? Now, what is this? Okay, I'm not going to, first of all, has anybody ever seen a plot like this? I'm not going to talk about it. It's something called a tree map, which, by the way, was developed by a guy who got his PhD at Stony Brook, so just so you feel a connection here. But who likes this? Who doesn't like it? It looks like it's showing every company by how much money it made, okay? And what do you see when you look at this? Okay? Do people see anything they understand, don't understand yet?
Just the captions are overwhelming.
So first of all, the captions are clearly overwhelming, and you can't read them for most of the place. Okay? Any other? So it's clearly there's too much going on here to grok at this point. Okay? Actually, the captions were kind of helpful in that they showed, that I learned that they did this, it was clear they did revenue by quarter or year rather than one per each company, because some companies are represented many times. And so what do I learn? Walmart brings in a lot of money, helping the people in Arkansas, right? And ExxonMobil does too. And the other companies aren't nearly as big. There's a color scheme. Do we know what the color scheme is doing here? Okay. I don't offhand know what the color scheme is, but the color scheme could have conveyed some kind of information. Maybe it did, okay, but it's certainly not clear what that information is. How might we have used color, actually? Any idea on how we could have used, where one might, if one were determined to draw this thing? Well, to help you understand, grok, what is going on here? Yeah.
We might have color by sector.
you might have colored companies by sector. So we would see, let's say, maybe purple was oil companies and one was retail. Maybe you would color all the records for a company the same. So all the Walmarts look the same, okay, and you get better coherence there. Or maybe you colored it by, which sector it was, which time period it was. For all of these companies, I think you had 4 time points, right? And if so, if they were consistently first, second, third, maybe that would reveal. So there's some way you could use it. This right now I can't grok, okay? Any questions? Okay, this is one that is showing me profit by sector, okay? And again, he says for each one of these sectors, 1, 2, 3, this is consumer discretionary, consumer staples, energy, financial. This shows what was the profit each year, okay? Now, so I understand what this is saying. It's showing me a lot of information. Is there any way that we could have done this better or show information more that would be interesting? Okay, yeah? So I do think that there is some question of combining years in a way to better make clear what's going on. Okay? So right now, it could be that if I, at the very least, I could imagine coloring the 3 bars for each sector, okay, the same. So I can see that they are kind of the same thing. Okay? I might want to have a device that brought those 3 columns together in a way that I could see whether they're going up or down. Okay? How might one do that? Yeah? Grouped bar chart, that's a word. I don't know exactly what that means. I assume, I have no doubt it means something. Okay, yeah.
You could group the sectors and you could stack the bars.
Could be you stack the bars. And stacking the bars, which we'll talk about stacked bar charts, I like, except that for this case, I guess this is going up, this is going up, this one is not going up. How you stack the bars it's not clear to me what the right order to stack the bars are in a way that would reveal that best. It could be that you add this for, kind of in each column just the 3 colored barks. This is how much our profit was in 1 year, 2 years, 3 years. Okay? Anyway, there's different ways to present this that would reveal what's going on. So if we take a look at it, materials. Did you want to be in materials? Materials with time seems to have dumped, right? You said, I want to be in consumer discretionary because they get a lot more profit. They're growing profit, right? You would like these kind of things to leap out at you. And if you have the right graphic design, you will see more than you see here. Okay? Any questions? Okay? This is showing the price of stocks in each sector. Okay? And, I don't know if people think this is good or bad. There's probably a mix here. What's good about it? There is a lot of data here. And maybe you can follow it for any sector, you can follow it. It may be there's too much data here. But there are pictures I'm curious about. My God, what happened to those purple people? Purple people looked like they were sailing along and whammo, right? What happened to the purple? What were the purple people? I wish I could see the color scheme better. What was the purple people that got hit then? You tell me it's information technologies? I'm not sure I got that color right. Are you sure that that's the right color? Okay, if that's true, IT really got hit. I'm a little surprised. I don't remember IT getting hit in 2014, but something happened to them, right? Okay, so there's a story being told here, okay? If you're measuring the right statistic, I'm a little curious what that statistic of high price of the stock, that may mean the daily high, okay? And, you know, and whether this is a return thing or something weird about you know, absolute stock prices, but I think you get an idea here. Okay, here's one where they're showing me for every something what is the total revenue, net income, and income tax. Okay? Good plot or bad plot? Okay? I think bad plot in some ways. Why? What am I looking up on the x-axis? The x-axis, I don't know what I'm looking up here. Okay, there's no particular order here where it is meaningful or interpretable. This is a plot that says this is a plot, right? Okay? And even so how would I make this better? First of all, I'd like to know, these are presumably something of company quarters, okay, or company half years or something like that, right? And I would want them grouped by company. I'd want them grouped by time. Maybe I would want a separate plot to compare how net revenue is dealing compared to income tax, okay? Because right now a lot of the income tax and the net thing are kind of lost. There's no visual resolution because they're all cramped to a tiny part. Does everybody see that there's ways you could present this information where something would come out of it? And right now I'm not seeing a story, okay? Any questions? Okay? So this I consider to be a good exercise for proving that plots that tell a story are better than plots that don't tell a story. Okay? And now I want to go to the, you know, heart of the lecture, which is about basically going to be how do you go and think about visualization in a way to increase the ability to tell a story. Okay? This is, again, this is a very useful skill if you can get good at it, okay? And the way you get good at it, like anything else, is with experience and thinking about it and coming to understand that there's a problem here, okay? So visualization is part of what, you know, this general field of exploratory data analysis, okay? Looking at your data for what it is there. Now, you know, there's a lot of reasons why you need to look at data. One is sometimes you want to understand what's going on in the housing market, in the stock market. To do that, you need a visualization of something. To be able to make a theory of how the world operates, you need to look at data and say, hey, this is probably because of something else. On a mechanical side of I am processing data for some kind of a project, okay? You need to be able to see when you goofed something up in either processing or you know, data collection, okay? To make sure that the data has the properties that you think it does before you feed it to a model. In general, feeding the data to a machine learning algorithm that you haven't done anything to visualize or clean or grok is a, you know, exercise in frustration, okay? It's going to learn something ridiculous from that, okay? And so I think that being able to look at this is an important test, okay? And as I've said before, when I see graphs from my students, a surprising number of them are really bad. And the reason for that is not that my students are stupid. It's that visualization is harder than it looks. And thinking about what you want that to tell, why you're doing the visualization, okay, is important in many cases. So, okay, so that's my motivation. One classic example in visualization, okay, as to why data visualization is important, is something that by this guy named Ascombe, who built 4 data sets with the property that the means, they're points in 2 dimensions, okay? They have x, y values. The means are the same for both the x and the y. The variance is the same in each column. The regression line is exactly the same. are these point sets the same? Okay? Looking at this data as a table, can you tell anything about what the behavior of these data sets are? You can see the numbers. They're big enough for you to read. Can anybody get a story of any of these data sets from looking at the numbers? Okay? There's some things you can do if you stare hard enough. So let's stare at this. Does anybody see anything at all in these data sets that suggests they're different or what they're doing? Yeah.
The first three columns are completely same, and the last column, I think all of the numbers are same except the 19.
Okay, so you think that the columns, wait, you think that the first columns are the same. Okay, the x values here are all the same. Okay, great. So in addition to having all those statistics, the x values are the same. Are the stories the same? What is the stories of the points? Can anybody see any story here by just looking at it? The numbers. Okay, I'm not seeing anybody who's telling me a story. Now you draw graphs. Now is there a story that is different? What is the story of this for one in the upper left corner? This story to me is of data that seems naturally, probably experimentally created data about collected data of a linear trend, right? What is the story here? Okay. Story here is that this is not a linear thing, right? Yeah, you can fit a regression line to it, but it's not going to necessarily make you a happier person, right? This is something that there's a rise and fall to. What does this one, the story of this data set? Okay. When you read this graph, what do you see? You see, this is something that's it's a perfect linear trend, except there is an outlier, right? So something wrong, somebody sneezed when they collected this data, okay, or something like that, right? And what is this? This is that y is independent of x, okay, except for that outlier, right? So again, when you see the pictures, you know instantly what's going on. And this is an argument that, the eye is needed and not just statistical summary statistics. Any questions about that? That I think you can readily believe. Now, there is a set of books I love on data visualization by a guy named Edward Tufte. And many of my examples are going to be drawn from his books. And, this is one of them, which had to do was data that was drawn from a presentation that NASA engineers were given trying to stop the launch of a space shuttle that blew up. Okay, again, this happened, you guys, again, I hate to think that you guys are young, probably may not have been born when the space shuttle came up. You understand the concept of the space shuttle, rocket ship, people on this, okay? The engineers were trying to decide whether or not, they were going to should launch the space shuttle. Okay, this was in 1980. This was, I think, in 1986, so maybe it was. Well, none of you guys were, your parents may not have been born then or something like that, okay? But still, what was going on? Okay, they had launched like 30 or 40 of these space shuttles, and there was a component called the O-rings that kind of kept the engines together. When you fire up an engine, there's a lot of pressure, something's got to tie it together so it doesn't separate, and that thing was called an O-ring. And the engineers said, hey, it looks like the rubber that controls the O-rings, okay, gets more damage on days when it's cold, okay? And we're launching tomorrow. It's colder than it's ever been, okay? And so the engineers are desperately going to management that says, we don't think you should launch this, okay? And so what did they do? They gave a presentation like this where they said, gee, management, okay, see, Here are a bunch of here are the engines we've had on all of our previous things. This shows the O-ring, the temperature every day. This shows, the darkness shows the amount of O-ring damage that we've had, okay, on that day. It's not safe. You can't launch this thing. What was the management's reaction when they saw this data? Okay. They said, you're a bunch of eggheads, and, I'm going to launch the thing. Okay? Now, here is that exact same data redrawn by this guy, Edward Tufte. Okay? It was a great visualization, and of course, is doing this in 2020 hindsight. What is he saying? My x-axis is temperature. My y-axis is the amount of damage to rings. Okay? And there's a dot for every single space shuttle mission. Okay? And what do you see? You see, okay, look, when the temperature's been nice and warm, we launched from Florida, very little damage. Okay, a couple of launches, there was a little bit of damage. But look, whenever the temperature got below 60 degrees, it looks like the amount of damage is growing. And, I don't have many points out there, but maybe it's nonlinear, right? And what is the temperature going to be tomorrow? Okay? Now, faced with this, do you decide to say you're a bunch of eggheads and we're going to launch it? Or is the issue now a lot clearer? People understand the graph? Okay, do people see how the points on this graph could have been obtained from this? Part of it, I guess, he talks about a damage index that was probably averaging the damage on each of the two engines. There were two of these things, right? And so, it's distracting to separate from what's on the left and what's on the right, and that's not important. Okay? So this is an example of a case where if you present the data right, the story is clear, and it can have life-changing consequences. Any questions? Okay, so that you understand. So from now on, let's look at talk intelligently, learn to talk intelligently about whether a graphic is better or worse. Okay? And to do that, I claim it's a lot like the problem of art appreciation. Okay? And that people have things that they like and things that they don't like. And they have some language to talk about it. Okay? So these are two famous paintings in the Metropolitan Museum of Art in Manhattan. Over break, I encourage you to go visit it. Okay? Does anybody know who painted the one on the left? I don't know if we've got any art fans here. Jacques-Louis Davis, The Death of Socrates. Does anyone know the one on the right? Yeah? Jackson Pollock, okay, whose house is actually, the house he had with his wife, okay, on Long Island is now kind of run by Stony Brook, so there's a little bit of a connection. Okay? Who likes the one on the left better? Okay, who likes the one on the right better? Okay, we see some kind of little disagreement. Okay, okay. Which one why do you like the one on the left? You need some kind of language for that. What do you see? Does anyone want to tell me what they like about it? Yes?
It's more realistic rather than fiction.
Realistic. Okay, anything else that makes this a great painting? Yes?
You see a story there, you see the thing you see Socrates, in his last moments.
You see, right, there's pathos here. Socrates is lecturing to his students while being given the poison by the government that's going to kill him. Okay, and he's giving the students a last lecture, a dedicated, example for all teachers, I guess, right? Except I'm not going to take anything you guys give me to drink. Okay? Any questions? Okay? There's a sense of pathos. Look at this thing. He's defiant. His students, the ones that really love him, there's people who can't take it. The soldiers, or these people, you see the pathos from those people. You can see these guys trying to listen and learn from their great teacher. Okay? What about the one on the right? Why do people like it? okay, or not like it? Or is there any value here? What is it? You claim to like it. What's the reason?
I was just telling him that I would not hang the left one in my house, but I wouldn't mind having
You want the one on the right. Okay, why?
the colors,
You like the colors, okay?
the patterns it makes. I
Oh.
would take the black out.
Okay. I will tell you, again, I like both paintings. The one on the right, when you go to in the Met, there is a sense of energy about this thing. When you look at this thing, you don't say, my God, the guy dripped on this thing and my kid could do that. You're feeling, you're following the swirls, you're seeing something is going on when you look at that, okay? With the right mindset. There's a sense of energy, there's a sense of rhythm, there's a sense of something, okay? And, the art critics that like this stuff have a language to talk about these things, okay? Okay, they are both great paintings. And, but developing kind of a sense of how to analyze this kind of art requires learning a language, some criteria for it. So, when it comes to analyzing math graphics, I want to talk about my man Edward Tufte's aesthetic for visualization. Okay? And when he talks about, he has these books that I say are wonderful, wonderful books. They're books of pictures, books of mathematical graphics that are good and mathematical graphics that are bad, and, reasoned discussion about why one is better than the other. Okay? And the principles he uses that I use to think about whether something is good or bad. One thing he says a good visualization maximizes data ink ratio. A good visualization minimizes the amount that it's lying to you. A good visualization modifies things that are on the graphic for no reason. And a good visualization uses proper scales and clear labeling. Okay? So let's go through these principles. What is the data ink ratio? This is kind of an idea here of, when you look at a graphic, what is the fraction of the ink that was used to print it that is used to represent the data versus the total amount of ink that was used. Okay? So we have two different sets of bar charts here. Which one do we think is a better visualization? Okay? Who likes the one on the left? Few people. Who like the one on the right? Which is the one that Tufte is going to like better? Yeah, the one on the right. Why? His claim is that there is ink here that is not being used to represent data. What ink is not being used to represent data? Okay, one is the third dimension. Okay, one is the shadow, right? Why is the shadow in the third dimension there? Answer is because it's cool. Okay? Now, on the other hand, does that help you understand what is going on in the data? Certainly visually, no. Okay? It's probably harder to compare how high the male incomes are for female incomes here. Okay? Or if this is income, or I don't know what the Y is here. That's not important. Okay? But it's clear that they're trying to show you that something is different for men and women have more of it, okay? And, that it seemingly differs by income level, okay? So, so that's one of the criteria that Tufte uses, okay? Another is the idea of the lie factor, the idea that the dimensionality is kind of the effect of what you're seeing in the plot compared to the effect that there is in the data. Okay? A plot is lying to you if it is showing you something more dramatic in the picture or less dramatic in the picture than it is in the data. Okay? So here is one that's kind of interesting. Okay? What is, let's look at the one on the right about the oil prices. Okay? What is this showing you about oil prices? Okay, what is the picture telling you? When you look at the picture, what is this telling you?
As time goes, the price has increased.
As time goes, the price is increasing? Is it increasing a little or a lot? You think the increase, as shown by the picture here, is a little. Okay? I think I look at this, my God, from 78 to 79. What is that difference? Look at the size of that barrel. How much bigger is this barrel than that barrel? Can anybody give me a guess? When you look at the size of the barrel, how big is the 1979 barrel compared to the 1978 barrel? Someone want to take a guess?
10 liters?
What?
10 liters?
Twice as much.
Okay, I guess the proportion. How much more oil is fitting in this barrel than in that barrel? Twice as much? Okay, yeah.
Well, it depends if you're looking at it 2 or 3 units as well. So the lie factor is going to be lower.
Okay, the lie factor is what you're seeing. What I'm seeing, if you ask me, let's put it this way. I give you a choice. I'm going to give you what you can get for the same price, 2 barrels of 1978 oil or 1 barrel of 1979 oil. Who would prefer to, thinks they're going to get more if they get 278 barrels? Who thinks they're going to get more if they get 179 barrel? Okay? If that's true, that would say that the visual effect is that this is twice as big as that. Whereas the actual price that it's supposed to represent is not twice as high. Maybe it's 10% higher, something like that. That is what the lie factor here is. Okay? When you're looking at this, okay, the numbers, yes, they're increasing, but the rate of increase looks like, my God, it's gone out of style. Okay? It's out of control. Okay? When it's not really as out of control as the picture shows. One reason is because three-dimensional volumes, kind of price is a one-dimensional thing, volume is a three-dimensional thing. How you compare that? That sounds weird, right? And you can imagine this with different graphics. Okay? Any questions?
I'm sorry, you mean that the volume of that, the one in 79 is twice times the one in 78?
So I don't know what the ratio of the volume is. I just know what my idea is. My look at this is this barrel looks a hell of a lot bigger than this barrel. Okay? That's what I see. Okay, yeah?
So isn't the size of the barrel supposed to be the same, but only the price is supposed to increase, right?
So certainly the prices of real barrels used in the oil industry is the same over time. These people are getting clever by saying, to show you how prices are increasing, I'm going to represent it by barrels of different size. That's what they're trying to say. And if so, then they're scaling something in the price of the oil at that time, right? If what they were doing was faithfully scaling the Y according to the what the value of X is, of what the price is, then that's somewhat understandable. But there's going to be a natural lie because volume grows kind of as a cube of the height rather than the, linearly. So your eye will be fooled. What other things do they do here to make this thing lie to you? Are there other things about the graphic thing where even if they represented the barrels like that, is there anything else that makes this misleading? I will say the fade in the back makes it misleading, right? If I want to say, how tall are you? How tall are you? 6'4". Who's taller, him or me? Him, right? Now what if I put him 20 feet back or 30 feet back and I ask you who's taller? Suddenly I'm going to look bigger, right? And that's kind of one thing that's happening here. This stuff is looking smaller than it should because it's going back, right? That's a lie. And I think the bigger lie is I assume that there's no real direct interpretation of these numbers were tacked on after they drew the pictures of the barrels, okay? So that's not what we want to see, okay? Any questions? And again, there's lots of different ways that graphics can lie to you. Here is a picture that was taken from a particular news report about how tax rates are going to change if a tax cut expires. Okay? What is this picture telling you? Can anyone tell me what the picture is? Tell me what is happening with those tax cuts. What's going to happen when the tax cut expires? What is the graphic telling you? Okay? Telling you it's out of control, right? The tax rate is going to, looks like it's going to triple, right? Why is that true? Well, they didn't start the axis on 0, right? They start the axis on 34. If you start the axis right and you're showing the full weight of the bars, what's going to happen when the tax cut is going to expire? Taxes are going to go up. Are they going to go up by a crazy amount? No. Okay, here it's out of control. Does everybody see that this is lying to you? Okay? And again, it turns out that many people would believe that this network likes the idea of lower taxes, okay, and thinks, you know, has a sense of this. Okay, so how do you make your graphic not lie to you? You should usually start things at 0. You have to properly label what's going on the axes. And you should probably use continuous scales, okay? So that, you know, it depends. Sometimes there's different kinds of things. Maybe you can use a log plot or something like that, but somehow, you know, you don't want discontinuities in this. Any questions? Okay. Here are 3 pictures of sales for a company, okay? As the sales that they had from February to October, okay? Which company is having the roughest time? Okay, it looks to me, which company is having the worst change in its business? Is it this one, or this one? Top right, these guys going out of business, it looks like, right? What is the same between all 3 of these plots? The data. The data is exactly the same in these plots, okay? What is happening? The difference is actually, the only thing that's really changing is the shape of the plot. They're all rectangles, okay? They are, you know, this one's squashed on the X, this is elongated on the X, this is, you know, somewhere in between. Which is the right one and which is the wrong one? What? What would be a criteria? Okay, which one do you think is the right one? The one at the, which one? The bottom? You like the bottom one, which seems to show everything's basically a mild change, right? Just a storm, little storm, you know, a couple clouds coming in. Yeah?
I would say the top left, because that's the most similar proportion with the X and Y.
You look at the top left, okay? You think this is the one that's easier to read. What do I think? Yeah? Okay, you like the bottom one because it, well, they all have the same points on them. The difference is where it's stretched, okay? So what is the one that lies the least, okay? You know, arguably they're all saying the same thing on some level. What I will say is that people are used to looking at graphics of certain proportions, okay? I will guess that you're used to seeing things that are in a proportion like the one on the upper left, okay? what looks this shape? A television set looks this shape, right? Television sets don't look like that. Which one of these look like a painting in the Metropolitan Museum of Art? I would argue that one of these things looks more like that, right? So you're used to seeing boxes like this, and maybe you have more experience in interpreting this, okay? So recognizing that you can have different effects on it, you should recognize you have this power, and recognize that you have the responsibility to try to present it as normal as possible. A figure like this, the dimensions probably follow roughly like the golden ratio. What is the golden ratio? People have heard of the golden ratio. What is the golden ratio? Actually, how many people here have heard of the golden ratio? Most people. What is the golden ratio? Yeah? Something like 1.61, something or other. It comes from some Fibonacci thing. It's the ratio of two successive Fibonacci numbers. The Greeks got excited about this kind of thing. But what is it in practice? It is that the ratio, it's 1.6 to 1. Do I believe that this x value is about 1.6 times the y value? I kind of believe that. I'd have to pull out a measurement to really believe that. But that's not really as true with the other ones, okay? And people are kind of used to the x-axis being longer than the y-axis. So it's not only that it's the ratio, but, this is what people are used to, and that's probably what you should be giving them, unless there is a good reason to. Any questions? Okay, good. And there's all kinds of great things in Tufte. I really recommend going to find Edward Tufte's Visualization of Quantitative Data book. This is one of my favorite things. It's the best book to read on the toilet because you're looking at a lot of pictures. And this is one that he showed where someone is showing you how, oil, the standards for how much gas per, how many miles per gallon cars have to get as a function of years go. What does this picture show you when you look at it? What is the message of the figure on the left? When you see this, what is your eye saying when you look at this thing? Here are the years. Here are the, the numbers for what the requirements are. What is this telling you? When you look at this, what do you think that they're trying, your reaction is supposed to be?
And it's growing exponentially.
Growing out of control, right? My God, these people, as the years get closer and closer, they keep demanding more and more. What does it look like when you plot it on a real thing? Okay, well, it says it's going up, but doesn't look like it's been that crazy, right? And so how you plot it tells a story or not story. Okay, any questions? Okay, there is another principle that Tufte has, which is this idea of trying to reduce the visual elements that distract from what the data is trying to tell. Okay, this is often extra dimensionality. This is coloring that doesn't tell you something. Coloring for a reason is great. It's excessive grids and stuff like that. When you have a good graphic, the data is telling the story. Okay? So Tufte calls the things you put on a graph that just to sort of decorate it a graphical duck after this building. Has anybody ever seen this building before? This building is on Long Island, actually, out, where is it? If you read where the Duck Building is, it's near Mattatuck, or it's somewhere slightly out east. It's not at the end of, it's not out by the Hamptons, it's on the way there. It was a building that used to be a store selling duck eggs, okay? Now, why does it have a head of a duck on it? Okay? Well, because the guy thought having a head on the duck is going to make it look good, maybe sell some duck eggs. but it doesn't really increase the functionality as a store, right? Okay, so we want to try to, so here is a graphic that Tufte considers the worst graphic ever to appear in publication. Okay, what is it showing you? Okay, it is showing you for the x-axis is years, the y-axis is the percentage of people on the bottom, 25 and under, that are enrolled in college. No, the bottom one is the percentage of people 25 and over who are enrolled in college. Up top is the percentage of people 25 and under who are enrolled in, or under 25 who are enrolled in college. Okay, do you understand what the measurements are supposed to be? This is measuring the frequency of people, older people going to college as a function of time. This is a measure of younger people as a function of going to college as a function of time. What's right or wrong about this graphic? Do people understand what the graphic is showing? Okay? What's right or wrong about it? Yes?
It shows older people are going to be more interested in have some education than younger people, which is.
So it tells you that older people are, what it's telling you here, if I take a look at what the data is actually saying, it tells me that younger people are more, this is telling you, take it back, this is the percentage of people, let's make sure we get this exactly right. This says when you take a look at the college enrollment at a place like Stony Brook, again, you don't have to hold up your hand now if this violates some privacy thing. Who here is 25 and younger? Or under 25? Some of you. Who here is 25 or older? Some of us, right? So this is showing, as a function of years, what fraction of people are 25 and over of the people at Stony Brook. And this is showing me what are the people who are 25 and younger, under 25 at Stony Brook. Okay? Now we understand it. So what does this tell me now? Okay? Yeah?
That over time they follow the exact same pattern, the same amount.
Okay, so what we might want to read from this is it says, okay, it looks like at Stony Brook they're getting more older students, right? Okay? And it looks like at Stony Brook you're getting fewer younger students, right? Now, is that an interesting result, the one on the top? No, why not?
One, because if you're here on the island, this is the only school that has an access.
Well, okay, forget about it being Stony Brook. There's mathematically a problem that you identified, which is that the percentage of students under 25 is 100 minus the percentage of students 25 and older. Does everybody agree? So all of these points, are they extra data, or are they completely derivable from the points below? Okay, I claim that the numbers on the top are mechanically a function. If I know that 30% of you are 24 or younger, I know that 100 minus that is how many people are older. Okay? So this is not data. This is new data. This is a function of that. Okay? What else is good or bad about this plot? So this whole thing up top, is this thing redundant? Okay? I think the answer is yes. Now, my question is, at this point here, this was the point they were closest. Were, in year 1976, were the number of old and young students almost the same? That's what I think I'm getting from this plot, right? Were they almost the same? How do you know? You say no, why not? They look close to the same. What's the deficiency here? Notice that they have this little squiggly thing? Look at the numbers on the axis. This looks like it goes 11, 14, 14, 53, something like that, right? Okay, so all this stuff is redundant or misleading, right? Anything else that's interesting about this graphic that looks misleading on some level? Yeah? The third dimension is providing no information, right? So it looks like we're using 4 colors and 2 colors are unnecessary, telling you nothing, right? Maybe misleading you. Is there anything else that's distracting or misleading about this? Can anybody see anything else that this is lying to you on? Yeah? It does not start from 0, so one thing that's true is it does not start at 0 down here, so there's a discontinuity here and here. Okay? So that is somewhat misleading. It's again the same kind of, yes, I agree with that. Anything else here that is misleading? Okay? What does the curvy shape here between years mean? Okay? Does everybody see they connected these things with curves? What do the curvy shapes mean? Means their tool draws curvy shapes. That's what it means. Okay? We don't have any data in between that, right? It's doing some kind of weird interpolation that has nothing to do with that. Really, you're using 4 colors to draw what are really only 5 data points in a misleading way. Okay, so this is an example of a terrible graphic. Any questions? Okay, so the idea of simplifying plots is a good one. Okay, so learning to look at when you have junk on a plot that can go away to make it better. Okay, it's worth knowing. Looking at this plot, which is showing something about presumably percentage of profit or sales or something like that as a function of time, is there anything that can be removed from this graphic to make it better? Yeah? You're saying you don't like the vertical lines. Okay? Tufte calls this a data prison, right? Your data is behind bars, right? So maybe you want to get rid of the prison. Okay? Does this look better? Okay. Is there anything else that can be gotten rid of here without anything? Yes?
Can we just make the bars into a line to show?
So one possibility is you're saying you're questioning the whole existence of a bar chart. You're saying, why don't I just draw the points instead of as bars? Okay? And that's now a question of taste. Some people like to see bar charts, okay? But I can give you, if I wanted to minimize maximize my data inc ratio, I could probably just draw a y value here, a dot, and that would convey it. But people are used to seeing money somehow in bar charts, so I'm not sure. I don't have a strong opinion here. You're not wrong. I'm not sure whether I would do away with all bar charts. Yes? You don't like the background color. You don't like the blue. Okay? It's gone. Okay? Now, is there anything else here that when we look at this that is redundant or not necessary?
I just want to say that we can't see what is the minimum or maximum of the number.
Okay, you're saying I think what you're saying, you don't see the minimum or maximum. You're saying you would like to be able to read the number values off. And what's stopping you from doing this? Okay? If we take a look, what's stopping you from doing it? Maybe they don't have a fine enough resolution of labels on the ticks on the y-axis. That's maybe a fair statement here. Okay? But so I understand what you're trying to do. I don't think I can do better by removing stuff. Anything else I can remove here that will make people happier? Yeah. You don't like the box, okay? Now the box arguably makes him a little happier because he's getting to read what